Hello everyone, welcome to another lecture. My name is Noah Scheinbaum. Today's topic is on perimeter, area, and volume. So let's get started with perimeter. Perimeter is defined as the distance around a two-dimensional shape. Normally what you'll do is you'll just take all of the side lengths, add them up, and find the perimeter that way, but there are a couple of cases where there are either formulas that you can memorize so that you don't have to do that, or formulas that you can memorize because you cannot do that in the case of a circle. So, some examples of these formulas is that for a square, the perimeter of a square equals 4 times s, where s is the side length. This is fairly self-explanatory because all four sides of the square are the same length. So the total distance around the square is just going to be the sum of the side lengths, which is 4 times one of the side lengths because all of them are the same. Following the same logic for the rectangle, the lengths are going to be the same length, the widths are going to be the same length, so the distance around the rectangle is 2 times the length plus 2 times the width. Now the circle is the first one that we have, and the only one that we have, that we can't calculate just by adding up the sides, because depending on who you ask, a circle has either 0 or infinitely many sides. So the circumference of a circle, which is a fancy word for perimeter when you're talking about circle, is 2 pi r, where pi is approximately 3.14 and r is the radius of the circle. This is sometimes written as pi times d, where d is the diameter, and the diameter is defined as twice the radius. For all other shapes, do not memorize any formulas, simply find the side lengths if needed, if they're not given already, and then add them up to find the total distance. So we don't have any examples for perimeter. We're going to move right into area. Area of some simple shapes. So there are 5 simple shapes that we are concerned with on the ACT. It's the rectangle, the parallelogram, the trapezoid, the triangle, and the circle. So, B is base, H is height, R is radius. Height must always be perpendicular to the base or these formulas will not work. The area of the rectangle is base times height. Area of a parallelogram is also base times height. Area of a triangle is 1/2 base times height. Area of a trapezoid is an interesting one. It's base 1 plus base 2 times height and then divide that by 2. Now, if this seems weird, there's a pretty good reason for this, and I've seen a proof without words on this, and it's awesome. You take the average of the bases. That's what this is. Base 1 plus base 2 divided by 2, that's the average of the two bases, and then you multiply it by height. If you rearrange the trapezoid in a certain way, making cuts and then moving pieces of the trapezoid to other places, you get something that either looks like a parallelogram or a rectangle, depending on how you do it. And then the base of that is just going to be the average of the two bases. So that's really awesome. I highly recommend checking out the proofs without words if you're interested. If you're not interested, that's okay, just memorize this formula. And then the area of a circle is pi r squared. It's not like the other thing where diameter also works for this. If you are given the diameter, you have to convert to radius. Okay, so here are some examples. Let's work through a couple of simple shape area problems. How about a circle with radius 14 meters? Well, we know that the radius is 14, and we know that the area of a circle is pi r squared. So the area is going to equal pi times 14 squared, which is 196 pi. If we were given the diameter, we would have to convert it to the radius by dividing by 2. And you could also write this, you can also multiply it out. I chose to leave it in terms of pi because it looks neater, but if you multiplied it out, it would also be correct. Now this trapezoid, the main difficulty of solving this problem is realizing which values are needed and which values aren't. And I'm going to pick 6 for my base 1, 8 for my base 2, and 4 for my height. Remember that I said that bases and heights must always be perpendicular to one another, and those are the only options that you can pick so that you have the bases are both perpendicular to the height. You can also say that 8 is base 1 and 6 is base 2, and you'll have no difference in your calculation. This is just what I chose. Now, area equals base 1 plus base 2 times height divided by 2. So adding these two bases together, 6 plus 8, you get 14. 14 times 4 divided by 2 equals 28. Now, 5 and 7 here are not relevant towards calculating the area. If you wanted to calculate the perimeter, you would do 5 plus 6 plus 7 plus 8, and that would give you 26, and that would be the perimeter, but for the area, 5 and 7 are irrelevant. Okay, how about this triangle? This triangle has a base of 18 and a height of 6, so the area equals 1/2 base times height. 1/2 times 18 times 6 equals 54. And then this rectangle, the area equals base times height. So you want to multiply 12 by 7 to get an area of 84. And then finally this parallelogram, same thing, area equals base times height. 15 times 6 equals 90. Okay, so how about more complicated shapes? Well, when you have complicated shapes, there's usually two different types that are tested on the ACT. You have complicated shapes that require additive methods to solve. That's used when two or more shapes are attached to one another. By solving these, you would find the areas of the individual shapes and add them together, hence the name additive. And then there are also subtractive methods. This is used when one shape is cut out of another shape, like you have a circle and you cut a square out of it and you're asked to find the area of what's left. So you find the area of the outer shape and then subtract the area of what is being removed. So our first example is going to be an additive method, and our second example is going to be a subtractive method. So here's our first example. Find the area of this figure. So at first it's a little weird, right? You can't really, it's not any one normal type of shape, but if you look at it closely enough, you can see that this is a trapezoid stacked on top of a rectangle, right? So this rectangle on the bottom, it's fairly easy to find the area of, right? Because base times height, the base is 9, the height is 2, the area is 18. This trapezoid is a little bit more difficult, though, because we are not given this value, we are not given the height of the trapezoid. We know that this is 4, we know that this is 2, so by subtracting, right, if this total thing is 4, and this part right here is 2, then this part up here also has to be 2. Following the same logic, if this total thing is 9, and this is 4, then this is going to equal 9 minus 4, which is 5. So we get this. Now, this is a lot more manageable, because now we have a trapezoid with 2 bases and a height. So, plugging it into the formula, 1/2 times 3 plus 5 times 2 gives you 1/2 times 8 times 2, which is 8. So now we have the area of the rectangle and the area of the trapezoid. They're stacked on top of each other. Now all we have to do is add. So the area of the total area of the figure is 18 plus 8 equals 26. Perfect. This is a classic example of something that looks daunting at first, but once you break it up into smaller pieces, it's not that bad. Okay. Our next example is a subtractive method, and this was a question that appeared on the ACT recently. So an ellipse with a major axis of length 6 inches and a minor axis of length 4 inches is inscribed in a rectangle as shown below. The region inside the rectangle but outside the ellipse is shaded. What is the area in square inches of the shaded region? Now, the ACT is not asking you to memorize the area of an ellipse, which is why it's provided here for you. So let's start by finding the area of the outside rectangle. Well, that's not difficult. We know that the base is 6, the height is 4, so the area of the rectangle has an area of 24, because that's 6 times 4. The area of an ellipse, well, it's given that the area of an ellipse is pi times a times b, where a is 1/2 of the length of the major axis. The major axis would be the longer one here, that's 6, and b is 1/2 the length of the minor axis, which would be 4. So, if the major axis is 6, a is 1/2 the length, a would be 3. If the minor axis is 4, b is 1/2 the length, b would be 2. The inner ellipse has an area of pi times 3 times 2, which is 6 pi square inches. So, now that we have the area of the rectangle and the area of what's being cut out of the rectangle, we can find the area of the shaded region. The region inside the rectangle that is not inside the ellipse has an area of 24 minus 6 pi square inches. Okay, perfect. We are done with area. Now let's move on to three-dimensional objects. As opposed to two-dimensional objects, which only have 2 dimensions, right? 3D objects have a width, a height, and a depth. The 3D object on the ACT all have clear bases, which means the following. 3D objects and their bases, for example, a cube has a square base, a cylinder has a circular base, a rectangular pyramid has a rectangle base, a cone has a circular base. There are many figures tested on the ACT, but luckily, volume can be generalized by simple formulas. Surface area is a little bit different, and that's why we're not going to be covering it in this video. We're going to have a whole separate lecture for surface area. Okay, volume of simple objects. Capital B is going to be defined as area of the base. For cones and pyramids, the more triangular looking ones, volume equals 1/3 base times height, area of the base times height. And then for all other figures, volume equals the area of the base times height. So, finding the volume of this pyramid. Well, we know that since it's a pyramid, right, the formula is going to be 1/3 times the area of the base times height. Well, this base is a rectangle, right? This base is a rectangle with length 10 inches and width 8 inches, right? So, the area of the rectangle is 10 times 8, which is 80. And now that we have the area of the base, which is 80, and the height, which is 6, we can plug it into the formula and get 1/3 times 80 times 6 equals 160. And that is the volume of the pyramid. Anyway, thank you so much for watching. Like I said, surface area will be a separate video. We look forward to you watching our future videos, and have a great day.